Hey everyone, here's going to be a quick video going over the different types of problems that you might see that involve average rate of change. There are four major types of problems. There's going to be graphically, from a table, from a given function rule, and from a word problem. Please remember that the key info that you need to be working with is your slope formula of y2 minus y1 over x2 minus x1. The major steps that you want to keep in mind are that you need to make sure that you identify what type of problem it is that you're working with. Make sure you use the given inputs to find the given outputs. Use that slope formula. Make sure to simplify your answer and double check that you answered the question that's given to you. Okay, so let's see some examples. First up, we're going to take a look at a graphical type of problem where I want to find the average rate of change between the x values of -3 and of 0. If you take a look at the graph, when x is -3, your y coordinate is going to be 0. It's this point right here, -3, 0. And then when your x value is 0, your y value or your output is going to be 3 in this case. So now you can use your slope formula, but also just as a little side note, you can also do rise over run, rise over your run number. And if you do that, then you're actually going to end up getting up 3, and then you're also going to get over 3. So it's a rise of 3 and a run of 3, 3 over 3. Remember, you simplify that down, and it's 1 is going to be the answer for this problem. So that was doing a problem graphically. That's not too bad. Let's take another look at a different problem. Okay, so now let's take a look at it using a table. Here, I'm giving you the information in table format. Our x values are inputs and our y values are outputs. And we want to use the domain from 1 to 2, meaning an x value of 1 and an x value of 2. If that's the case, that means I'm going to be looking at this point right here. And I'm also going to be looking at this point right here. Okay, so when we write that out, it will be 1, -1 as one of our coordinates, and 2, 9 as the other coordinate, and we use our slope formula of y2 minus y1 over x2 minus x1. We do our substitution, and we end up getting 10 over 1, which is simply 10. So our average rate of change for this problem is 10. So that was an example using a table. Next up, let's take a look at doing an example with a function rule. Now this one is the type of problem that requires a lot more work because you're going to actually have to do some calculations. Remember, you're going to input 0 and you're going to input 3, both separately, and for x, to find the corresponding outputs. So that means we're looking at f of 0 equals 6 times 2 to the power of 0. Well, anything to the power of 0 is 1, so it cancels on out. So you're left with 6. That means our first point is going to be 0, 6. And that should make sense because if you recall, this is actually a exponential function, and the coefficient to the base, that's going to be your y-intercept, and that happens to be a y-intercept coordinate there because your x value is 0 and your y value is a constant. In this case, it's 6. And then we're going to do the same thing for the other x value. It's going to be f of 3 equals 6 times 2 to the third power. Now you can type this into your calculator, but 2 to the third power, that's going to be 8. 8 times 6 is 48. So it's going to be 3, 48 as our other coordinate, and now we can use our slope formula of y2 minus y1 over x2 minus x1. Substitute in 48 minus 6 over 3 minus 0. 48 minus 6, that's going to be 42 divided by 3. 42 divided by 3, we're going to then simplify as being 14. So our average rate of change in this problem is 14. Let's do one more example. Okay, so now the last example is actually a word problem. And this word problem says, a climber is on a hike. 1 hour into the hike, the altitude is 75 feet above sea level. 4 hours into the hike, they are 300 feet above sea level. What is their average rate of change? Now this one actually isn't too bad because they're telling us what our time is and what our altitude is. In this case, our time is going to be our independent variable, our x, because time cannot be influenced by altitude, but altitude can be influenced by time. So our coordinates are going to be 1, 75. That's for this first set of information right here. And our second set of information is 4 hours into the hike. They're at 300 feet. So that means that we're going to have, 4, 300. And then you're just going to use your slope formula just like before. y2 minus y1 over x2 minus x1. So it'll be 300 minus 75 over 4 minus 1. If you hear scratching in the background, that's my dog. Sorry, Percy's getting comfortable. To finish this off, that'll be 225 divided by 3. And in that case, that can actually simplify down to 75. And it's not just 75 in this case, it's 75 feet per hour. I'm just running out of little space here, so 75 feet per hour. So just to recap, this is an example of a word problem. Then, let's see here, this was an example of doing the problem with a function rule. This was an example of doing a problem with a table. And this was an example of doing a problem graphically. I hope you found this video helpful. Have a good one.